Thanks, Cam. So over the last few years, the GSV has been trawling through all the open file mineral exploration reports from the Stavely project area, compiling all the data and validating it, so it can be now imported into GIS and mining software. The data has been compiled predominantly from company exploration reports. In total, over 1,800 reports were interrogated, and roughly 800 of those reports contain data that we wanted to extract. That included extracting handwritten and deciphering handwritten text, such as that image there. You can pick out a couple of the words in there. Probably the most obvious is the greenstone rubble in the middle there. Our aim was to capture absolutely everything that we could from these reports, and that included pulling out alteration and mineralisation from comments into their own fields so that they can be queried and plotted. We collected 30,000 surface geochemistry samples, and that almost doubled the current data set. All samples that had already been collected were also revisited so that any missing data could be added. And we collected 10,000 drill holes. Roughly half of those drill holes were for mineral sands, the other half targeting metals. And we made a call to capture mineral sands, lithologies and assays into their own tables, as the data for those is quite unique compared to the other mineral exploration drilling. That ended up with 11 tables of 100% newly acquired data. Things like lithology and structure hadn't really been captured before, as previously we'd been focusing on just capturing colour locations. Have a look at exploration activity over time. The red and orange colours there are the drill holes, and the greens are the surface samples. You can see there's a nice peak in the early 90s there, bookended by increases in surface sampling. If we have a closer look at the surface sampling, main companies at the bottom there, WMC very busy early on collecting stream sediments and soils, CRA in the middle there collecting a lot of rock chips, stream sediments and soils, and lately we've had an increase in soil sampling. The mineral sands drilling, CRA kicked it off in the early 80s, and that led to the discovery of WIM 150 deposit. And more recently, Basin Minerals and Iluka have been quite active explorers. The metals drilling was kicked off by Pennzoil in the late 1970s, and CRA, again, very busy there during that period of peak exploration. This image nicely shows the areas of outcrop highlighted and the areas covered with a shade. You can see there. And if we plot the surface geochemistry, you can see it really nicely correlates with those areas of outcrop. And again, the metals drilling also has a pretty good correlation with those areas of outcrop. If you have a rough boundary between the outcropping areas and the covered areas to the north, you get the mineral sands drilling. So the key points for the surface geochemistry, we've got good coverage in the areas of outcrop. However, there's been little surface sampling over the last 20 years, particularly for rock chips and stream sediments. And copper, lead and zinc are the most common elements assayed for. And interestingly, gold has only been assayed for in roughly 30% of the stream sediments and half of the soil samples. If you have a look, this lack of multi-element geochemistry is clear in this graph. You can see there is a high proportion of elements that have been really analysed for, and information on analytical methods was often not provided in the reports. We'd be confronted with an assay sheet which just had an element, a number, and no information on how that number was determined. For the drilling, the average drill hole depth was just under 30 metres. Initially I thought that was bias from the mineral sands holes, but when we calculated for the metals, it was in fact around that 30 metre mark. That's probably because there's been quite a lot of air core and RAB drilling, and that appears to have just tagged the top of basement, grabbed a sample and moved on, and that might also explain the fact that 40% of the holes targeting metals have only one assay or were not assayed at all. So if we have a look at the diamond drilling, you can see it's quite sparse. It's only 1% of the data set. And there's only 3 holes that have gone beyond 500 metres there. PRC3 in the south will be on display at the core shed tomorrow. And if we have a look at this histogram, you can see the majority of those drill holes terminating at depths between 10 and 50 metres. The mineral sands holes are generally not assayed. They tended to be lith logged and had the CPS measured. Copper, lead, zinc and gold are the most common analytes for the metals targeting holes, and there's limited information on the analytical techniques and generally high detection limits. Again, you can see the copper assays there. The detection limit doesn't get below 1 part per million for any of the samples. And if you were assaying those samples today, you would expect a detection limit more around 0.2 parts per million. So the conclusions are the biggest thing to come from the historical data compilation was that mineral exploration almost entirely focused on those areas of outcrop, leaving large areas of the Stavely project area essentially untested. The drill holes appear to be undersampled, and with the limited analytical suites used by the previous explorers, combined with the advancements in technology, there's an opportunity to go back to areas that have been previously explored and resample. So an example of this would be the Fairview gold deposit that was identified in the mid-2000s by a gold in soil anomaly in a relatively well-explored portion of the Stavely project area. So who knows how many other anomalies might have been missed. If you would like any more information, you can come visit the booth outside, or you can go to our search assistant to download a copy of the report and the accompanying data. Thank you.